will start the depression cases here. This is a young girl who suffered from depression. You can see here the doctor labeled this girl as a moderate depression episode, and we can see the raw data here and a lot of frontal alpha activity. In the clean data, in the raw data in our iSyncBrain analysis is the reference montage, and the clean data is the common average montage. The montage is different. And in the depression, we typically see the frontal activity is quite pace linked, pace synchronized in the depression patient. So we can find how synchronized the frontal alpha activity in the connectivity map or the power map. But usually depression showing this kind of typical synchronized alpha pattern in the frontal area. And we can see this girl having a lot of alpha activity in the overall channel. And in the component, we can see the first component in the depression, typically the alpha activity from the healthy alpha activity in the posterior area is coming forward direction. That's the depression. Alpha activity should be in the posterior visual cortex area, but in the depression, the alpha activity is diffused in the anterior direction. And finally, the frontal alpha is dominated. That is the typical depression pattern. In the component, you can see the first component start coming from the superior temporal gyrus. You can see the x equal right hemisphere, y equal -35 is the back of the head, but the posterior occipital area is usually y equal -90. -35 is not so posterior area, it's the temporal area, right temporal area, having this kind of alpha activity. Alpha activity not coming from posterior area, but coming from temporal area, right temporal area. And the projection is the posterior area, T6 posterior area, and also the frontal area. The dipole having both opposite direction, projected in both opposite direction. In this case, T6 has the largest alpha activity. Usually, largest T6 alpha is the biomarker for the emotional trauma. So you can here the T6 alpha in the spectra. Usually, this is eyes closed recording. Usually, highest alpha activity should be in O1, O2, but in this case, T6 alpha is the highest amplitude. That means the emotion perception area is not working. So that's the very famous EEG biomarker of the emotional trauma. And the same kind of slow excessive alpha activity in the component is coming from the temporal, right temporal area. The component is ordered in the arranged in the order of the power. The first component is the biggest effect in the sense level EEG. So T6 alpha is largest for is depicted her emotional trauma, and second one is the cingulate alpha activity. The cingulate alpha is the midline and the posterior and just above the horizontal line. That's the typical alpha activity, is the healthy component. And the third one is the left parahippocampal alpha activity. That's the another temporal alpha activity. Is not healthy one. The alpha should be occipital area in the eyes closed. she has a left temporal alpha activity in the number 3. And number 4, we can see the supramarginal. Supramarginal is the right posterior and the above the horizontal plane. So this is very close to P4 area in the sense level. The coming from the supramarginal gyrus, and the direction is you can see the red dot is the origin of the dipole, and the small line is showing the direction of the dipole. This supramarginal gyrus alpha activity is supramarginal gyrus in the left is associated with the language processing or mass processing, and right is the emotional processing. Integration of the emotional information is not working very well too in these cases, in these depression cases. And so this is also the T6 alpha and P4 alpha is the both unhealthy area we have to target. And another one is precuneus. The precuneus is the usual alpha source, midline and the posterior alpha. This is the healthy alpha. And another one is the oncus. Oncus is very central structure of the temporal area, right, central, and very low position temporal structure, also having this kind of slow alpha activity and a little bit theta activity. And the projection in these two directions, bi-direction, the positive projection is here and negative projection in the temporal. And we can see this temporal alpha activity, temporal or theta activity is also unhealthy kind of depression associated with the depression symptom. And the next component is the fusiform component. Fusiform, here we can find blue is more bigger value. So the dipole source is close to the blue, and the red is here. So you can see the source is the right posterior area, and just below the horizontal line, that's the fusiform area. The phase perception, visual information area. So I think this is the normal alpha rhythm from the back of the head. And this is the horizontal eye movement. We have to reject, AI reject this horizontal eye movement and very slow frequency spectra. And this is the vertical eye movement, also rejected. And number 10, she has a central cingulate slow activity, slow theta activity. And 11 is the middle temporal slow activity. This is also unhealthy alpha activity coming from the temporal area, and this is the frontal alpha activity. You can see the right central and very high position. So this is the projection is like this. So the right posterior direction. So we have the largest amplitude in here. Blue is also largest value, but larger value, but the dipole source is between the red and blue in the right frontal area. So this is another unhealthy alpha activity in the right frontal or right central. And you can see the blue is more larger here. So dipole source is close to blue, not here. This is the frontal slow activity. She This is the theta and slow alpha activity coming from frontal. And this is also blue is blue and red. In this case, red is bigger. So we can find the source between this blue and red. The left, you can see the left frontal source activity a little bit slow. And number 15, this usually the tiny artifact, you can see very slow activity coming from the localized area, all rejected by AI as artifact activity. So we can see in this depression patient, there are a lot of temporal slow activity, temporal slow alpha activity. So we can find, and also the frontal slow activity, you can find that in the 1 Hertz bin spectra. So here, there are slow alpha excess in the frontal and the right temporal excess in the 8 and 9 Hertz. We already saw the T6 amplitude is very large, and there is also excess in the frontal area. We can find the frontal activation. You can see this is the frontal source. The source amplitude is not so big, but that makes that kind of slow activity, number 13, especially number 13, number 14, this kind of slow activity makes this kind of slow excess in the 8 and 9 Hertz, I think. So there are a lot of temporal excess in the 9 and 9 Hertz and 11 Hertz, and also frontal excess. The temporal T6 and P4 alpha activity is the emotional trauma, and also reflective emotional trauma, and frontal alpha, slow alpha excess is reflection of the depression. And also global alpha rhythm showing the fatigue, usually in healthy population having this kind of alpha global pattern. That means also posterior alpha move toward anterior direction, and global alpha means kind of fatigue status of the brain. So the brain need to more relax. In the case that there are global fatigue pattern and also emotional trauma and the frontal alpha excess, this is the typical depression pattern of the QEEG. And we can find the deficiency in beta activity. And in the spectra, you can see the T6 alpha is largest, and the P4 is also larger. And you can see the frontal alpha is also excessive. And the same thing, the alpha frequency itself is quite normal in this case, but alpha excess in the frontal and temporal area, that's the problem. In this case, you can see the theta beta ratio is normal. Alpha is very high. That's why delta alpha, theta alpha ratio is very small in the T-score. And the source map, you can see she has a lot of hyper theta connectivity between the right frontal and the left occipital area, and a lot of hypercoherence between the frontal area. That's the typical depression pattern of the hypercoherence, alpha hypercoherence. And we can also match this alpha hypercoherence with this kind of pace synchrony in the alpha, in the frontal area. this is the oscillation pattern, and this is the connectivity measure coming from that kind of time dynamics. So there are a lot of alpha hypercoherence in this depression patient. And you can see the slow alpha is more larger in the right brain compared to the left brain. So that's why she has a lot of emotional problem in the right brain. And in the same thing we can see in the 3D map. This is the delta. We need to go through the alpha activity. And you can see in the left, the alpha 1 activity like green, but in the right, there are a lot of alpha excess, T6 people, and also in the frontal area too. And we can go to the alpha 2. Frontal alpha excess is the typical pattern of depression. She has a large excess of the right frontal area and also in the right parietal and temporal area compared to the left. So she has the right brain problem and also the frontal problem. This is the typical depression pattern. And then we can giving this depression patient for QEEG-guided photobiomodulation. For example, I think we can give the photobiomodulation based on this QEEG profile. For example, here we can speed up the frontal area, for example, like this, and the temporal area too. So starting the frequency from, for example, 13 Hertz, then we can gently activate frontal and the temporal, right parietal area and right parietal temporal area. At the same time, we can increase these two slow area using this kind of protocol, and we can tune the frequency from 13 to 14. That kind of the temporal, that kind of gradual increasing the protocol more faster frequency that makes this kind of frontal right parietal temporal hyperperfusion QEEG pattern. We can target these two areas at the same time. We can regulate the emotional circuit and making the depression patient more resilient in the emotional processing. So that's the QEEG finding. Once we can get the QEEG from this patient, we can find many abnormal component information from iSyncBrain. We can see this kind of right parietal temporal abnormal component. We have the MNI information of this abnormal source information. The TMS population using the TMS coil for targeting the abnormal area using this MNI information. And she also has the frontal slowing like this, number 13 and number 14. This the frontal slowing component frontal slowing source, we can target that frontal area for the TMS or the PBM like this. And then we can monitor the change of the progress using the another follow-up scan. That's the we can try the QEEG-guided photobiomodulation or QEEG-guided TMS, finding the location using the QEEG scan and choosing the frequency and communication with the patient and their feeling and their progress. We can slightly tune up and down the frequency. And once scanned, we can find the problem area, and then we can choose the frequency and tune up and down and making the symptom more better. That's the QEEG guided photobiomodulation protocol in the iSyncBrain. Do you have any comment? That's the brief introductory cases of the depression, how we can understand depression using the iSyncBrain and how can design the TMS target and the frequency or the PBM target and frequency for the depression.
Yeah, that's great. What would you say if someone was doing TMS then? How would that help with their protocol design?
Yes, they can scan their patient and then upload EEG. And they use, just in case they use the iSyncWave, they can directly finding the iSyncBrain analysis. Just in case they use another device, they can upload their EEG in iSyncBrain site, and then they can find the location of the depression patient, abnormal component location. In the component, we already give the MNI information. Where is the abnormal oscillation starting from in the component information? In using that MNI information, the TMS machine, usually some TMS machine having the navigator software. In the navigator software, they can input the target location using the MNI coordinate. Then in this case, for example, if they want to stimulate frontal area, then they target this frontal area. The cell X equal 10 is the midline, Y equal 55 is the very frontal area, and Z equal minus 25 is just below the central line. So the anterior and the below portion of the frontal area could be a TMS target. It's not the frontal, the front, under the minus 25 means the kind of orbitofrontal area, not the upper frontal area. So they could target the orbitofrontal area using that MNI information for trying to that kind of targeting, making this component location activated. That's the too easy guided the TMS navigation.
Okay. Yeah. And then could they also do the right temporal if they wanted to target the right temporal for this particular case?
Yes, right.
Okay, got it.
Yes, if they want to the right temporal area, then they can target the right temporal. But the PBM is more useful in terms of network activation. So we can choose two different areas at the same time, like that. You can choose two different areas, and trying to stimulate both areas together. But I think TMS, it is difficult to targeting two different areas at the same time.
Right.
But
Okay.
using the PBM, you can target both areas at the same time. So for the TMS people, I think they can, in the frontal, there are a lot of different areas, but some TMS navigation software having the input of the MNI information of the target stimulation location. In that case, they can use this information. In this case, not the frontal coil here, but a little bit on the orbital frontal direction, they can target.
Okay.